Hi guys, one more video, and this time I'm going to analyze a frame structure. Again, I'm taking the example from the same book. This example number 3.4, and in this example you can see that the frame is 10 feet high and it is 10 feet, the span is also 10 feet horizontally. The forces are, there is a 20 kg force applied horizontally and a distributed load of 5 kg per running foot is applied on this beam. Very simple problem. Let us try to solve this with STAAD and see whether we can meet the results. Our results will be accurate enough, or what will be the difference. Let us start STAAD. New project, plane, example 3.4, Allen Williams. Units are feet and kilo pound. Next, finish. As usual, I am not going to take advantage of this one. Now let us input the node numbers and their geometry. So node number 1, as usual, we assign 0 0, that is origin. Node number 2 is x0 y10. Node number 3 is x10 y10, and node number 4 is x10 and y0. So here are the 4 nodes. Let us join them. Let me put the node number on. Okay, so let me join node number 1 and node number 2, node number 2 and 3, and then 3 and 4. Very simple. Node number 1 is a pin support. Let us assign the pin support. And node number 4 is a roller support. As usual, I am going to assign a fixed butt condition support. Assign, close. Now we have to assign some member properties. Let us select all beams and let us assign some W section. Close. Now we have to assign forces, loads. Let us add a load case number 1. Add. Let us add the loads. There is a nodal force in positive x direction of 20 kip, and there is a member load which is minus 5 kip per running foot in y direction. This 20 kip force is assigned at node number 2. Let me assign to selected node, and this load is applied on this member. So I have applied this distributed load on member number 2. Let me close this window. Let's see. No need to show these forces. No need to show the sections, but I will put the beam numbers and member number on. Let me add the analysis command. Is added. Let us save. Analyze. So no error, no warning, no notes, done. Let's go to the post-processing mode. In post-processing mode, we are not going to have any deflection. I don't want to show the deflection now. And let's see the reactions. And the reactions, what we get at node number 1, in x direction we have minus 20 kip, and in y direction 5 kip upward. And at node number 4 we have 45 kip upward, which matches with the analysis results. Now we have to see the results in the beams. I don't want to show anything. Let us select one by one. Let's select member number 1. Member number 1, it shows an axial force of 5 kip and a lateral force of 20 kip. How we can establish this Fx is axial and Fy? Because these forces are defined in local coordinate system. And instead, the local coordinate system is defined from first node to the second node. The first node is called I, second node is J. So if we draw a line joining I to J, so in this direction, this will be X. And using our right hand rule, as per this member, if X is upward, then our local coordinate system, the Y will be in this direction. That is the opposite of global X. And of course, the Z will be pointing towards us. That means for member number 1, at node number 1, the Fx, which is the axial force, is in upward direction. And at node number 2, this is minus 5, which is downward direction. And at node number 1, the Fy is positive. That means it will be in negative global X direction. That means it will be acting on the left hand side. And at node number 2, it will be acting on the right hand side. Now let's verify whether this is correct or not. Let's go back to the model. So here is the free body diagram. This shows member number 1 and 2. We can see at node number 1, the Y is the force which is acting upward. For us it was Fx. This is the axial force acting upward here. And at node number 2, the axial force, which is 5 kip, is acting downward. And we have at node number 1, the horizontal force which is acting on the left hand side, in the left hand side direction. And at node number 2, the force 20 kip is acting on the right hand side. And here we have a moment which is M12. This moment is 200 kip fit. And let's see what our result shows. So at node number 2 we have a 200 kip fit MZ direction. That means the MZ vector is pointing towards us. Similarly, if we see the shear force and bending moment diagram, let us try to get the shear force and bending moment diagram for this member. So what I will do, I will select this view. I will view only this selected object, and let's see the shear force diagram first. This is the shear force diagram Fy. Let me show the result. Values, beam, shear force at end. We can see that the shear force acting on this member number 1, is 20 kip, which is exactly the same as this one, shear force diagram. Now I will see how the bending moment diagram is shown. MZ, this is the bending moment diagram. Here let's show the values. Beam, bending moment at the ends. So I don't want to show the shear force. This is 200 kip fit at this point, and of course here it is 0, 0, 200 kip fit. That means our bending moment diagram and shear force diagram are the same. Let's see the other member also. This member is between 3 and 4. Only one force, which is vertically acting downward here at node number 3, which is 45 kip, and here it is acting upward. Now let's see this selected object only, and here we have only axial force, which is 45. Let me show the values. Beam, axial force 45 kip, uniform, acting top to bottom. So that means we can show this diagram with end forces, the same thing. Now beam number 2 or member number 2, these are the forces which are acting, and this is the shear force diagram, and this is the bending moment diagram. Let's view the selected object. Let's first see the shear force diagram. The results can be seen. Shear force at the ends, 5 kip and 45 kip, 5 kip and 45 kip. Now I can show the bending moment diagram. This bending moment diagram is something like this. Let us enhance this little bit. Okay, I can go a little bit more. Now you can see this curvature. Here this value is less, somewhere here is higher. Let me show the values. Bending moment at the ends and maximum. Oh. These are overlapping. We can try to control. Unfortunately, these values are overlapping, but we can verify. Here, bending moment, member number 2. So the maximum here is 202.43. So this is the maximum value, 202.43. Here is 200 and the maximum is 202.5. So exactly the values are matching with slight difference in the decimal point, which is ignorable. So we will ignore that difference. And now I can say that we have completed the analysis, and we noticed that the values coming out from STAAD are matching exactly with the values given in the book. That means we can safely use STAAD. The second thing is that we learn here how to interpret the results, how to interpret the bending moment and shear force diagram. Hopefully you will appreciate this tutorial, and please do not forget to subscribe my channel, and do not forget to give a good like. Thank you very much.